There might be some time in your life that you will need to rewrite an equation or a formula. For instance, let's say I had the formula distance equals rate times time. Sometimes I might know the distance and I know the time, but I want to know how fast I would have to go to have that happen to cover a certain amount of distance. I could have something, this is actually the volume formula for like a pop can or something like that. I might have a fixed volume, like I know how much liquid the can needs to hold, but I want to manipulate the radius, or I want to manipulate the height. There also might be a time where in an algebra problem, we want to do something that's called substitution. So I would need to solve for one variable so that I can substitute it in the equation to find the other variable. So there are going to be some times where we will need to rewrite an equation and a formula. So in this lesson, you will learn how to solve a linear equation or formula for a specific variable. All right, so we're going to start with a little review here. We're going to be solving for a specific variable. They'll still be linear equations, but generally there's going to be more than one letter in the problem or variable in the problem. These problems, although I know that most of you are pretty used to solving them without using a mobile balance, I'm actually going to be solving all of these problems using a mobile balance because I think they just make more sense. So I'm going to encourage you to do that as well. So we're going to start with the 2x plus 5 equals 11 and just refresh your memory on how we would solve it using a mobile balance. So I'm going to draw a mobile balance. On my left side, I have 2x's and 5. And then on the right side, I have 11. Okay, we want to isolate the x's, so I don't want the 5 over here. So to get rid of 5, I'm going to subtract it from that side, which means I also have to subtract it from the right side. 11 minus 5 will give me 6. And then from here, I see that I have 2 x's, and I could actually write my formula if I wanted to. I have 2 x's equal to 6. And then from here, we just know if I have 6 and I want to divide it in between 2 x's, dividing 6 by 2 will give me x equals 3. Okay, so that's just a quick refresher on how to use a mobile balance. So now let's just go ahead and get into some formulas that look a little different. So I'm going to have x plus c equals k. All right, so I'm going to start with my mobile balance, and the equal sign again separates my left side and my right side. So on the left side, I have an x and I have a c. And then on the right side, I have a k. And just a little bit different because we don't have numbers, but that's okay. I'm solving for x, it says. So I sometimes even like to circle the x or make a different color or something like that. So I want the x to stay here. I don't want the c. So just like on the other problem, I didn't want the 5. I subtracted it to get rid of it. If I don't want it over here, I'm just going to subtract it. But that means I also have to subtract it from the other side. So if I look now, the x is isolated. I'm left with the x. And on the right side, I have k. And then I have that minus c. And then that's my answer. That's all you have to do, and it is solved for x. All right, so let's try another one. This one says to solve for x once again. We have 3x minus m is equal to p. So again, I'm going to start with my mobile balance. On the left side, I have 3 x's and minus m. And then on the right side, I have a p. So again, we want to isolate the x's. So I want the x's to stay, but I don't want that minus m. So if I don't want the minus m, the way that I'm going to get rid of it is to add it, which means I also need to add it to the other side. Okay, so now if I look what I have, I still have 3 x's on the left side, and on the right, I have a p and I have an m. Notice I'm not going to try to put them together, I'm just adding them together. Okay, then from here, if you guys remember from that first example when I had 2x is equal to 6, we simply divided both sides by the 2. So on this side, I'm going to divide by the 3. So I'm going to divide p plus m by 3 x's, and so that is my answer. So I'm going to get x equals p plus m all divided by 3, and that is it. So notice that the answers turn out a little bit different. There's really not a lot of math you need to do with it to simplify it. Okay, I'm going to let you try this one. So what I would like you to do is go ahead, write the problem down, and then I would like you to attempt to use a mobile balance, please. And then when you are done, come back and see how you did. Alrighty, welcome back. I'm going to go ahead and work it out and see if you agreed with me. First of all, it says 5 x's, so I'm going to draw 5 x's and then an L. And then on the right side, I have 2 R's. Okay, so now I want the x's to stay there. I don't want the L, so to get rid of the L, I'm going to subtract it. So we Scribbling it out means I subtracted it. And now I'm going to look at what I have. On the right side, I still have 5 x's. And on the right side, I have 2 r's, and I have that minus L. Okay, and then from here, just like the other problems, since there are 5 x's, to just have 1 x, I'm going to divide by 5. So I'm going to divide by 5. And then I'm just going to rewrite. So I'm just left with x, which is going to be 2r minus L, all divided by 5. And that will be my answer. Okay, keep them going on. This we're going to be solving for y. The next problems 4, 5, and 6 are going to be very popular when we go to graph equations. When we go to graph linear equations, we usually want them to say y equals. So this time, notice I'm not going to solve for x. We're going to practice solving for y. Process is the same. So let's see. I'm going to go ahead and get my mobile balance set up. And I hope that you are still drawing your mobile balances, because especially on these problems, it makes them so much easier. So first of all, I've got 2 x's. And then I've got 3 y's. And then on the right side, I have 12. Okay, so this time we want to solve for the y's. So I want to keep the y's. I want to keep all these y's over here. I don't want the x's. So if I don't want them, to get rid of them, I would subtract them. So I'm going to subtract them from the left side, which means I also need to subtract them from the right side. So now I'm going to write what I have. On the left side, I see 3 y's. And on the right side, I see 12 minus 2 x's, okay? And then from here, I am going to go ahead and, just like we did on the other problems, we can simply just divide by 3. So I'm going to divide by 3 and divide this side by 3. Okay, please notice one thing that I'm going to do on this side though, because when we go to graph something, we will want to do this step. I'm actually going to try to see if I can divide both of those parts by 3, if at all possible. 12 divided by 3 is 4. And then I'm going to bring that down, that minus sign. 2 divided by 3 doesn't work out nicely, so I'm just going to leave it as 2 over 3x. So that is what it would look like in y equals form. And if that didn't quite make sense, I'm going to do another one for you, with you. Okay, so another one, solve for y. So again, we're going to start with our mobile balance. It says I have 4 x's, 1, 2, 3, 4, and then minus 5y, so I have to do 5 of the minus y's. And then on the right side, I have 15. And again, we're trying to solve for y, so I want to keep these y's over here. I do not want the x's, so to get rid of the x's, I'm going to subtract from them from the left side, which means I also need to subtract all 4 of them from the right side. And so now I'm going to write what I have. On the left side, I have negative 5y's. And then on the right side, I have 15, and then I have minus 4 x's. Okay, then from here, just like we were doing in all the other problems, we're going to divide by that negative 5. So I'm going to divide by the negative 5. And because of the type of problem, I could leave my answer like this, but I know where this problem is heading, so I am going to go ahead and divide that negative 5 into each part. So 15 divided by negative 5 will be negative 3. And then negative 4 divided by negative 5 is going to be a positive, but 4 divided by 5 does not work out nice, so I'm just going to leave it as 4/5 and then x. And so that would be my answer solved for y. Okay, number 6, it is your turn. We've got 6x plus 3y equals 6. What I'd like you to do is go ahead and write it down. Please remember that we are solving for y. So if you would go ahead and draw your mobile balance and see if you can get it solved for y. When you're done, come back and I will work it out to see how you did. All right, welcome back. Let's go ahead and draw our mobile balances here. Notice it says 6 x's, so I'm going to draw 6 x's. 1, 2, 3, 4, 5, 6. And then we've got 3 y's, 1, 2, 3. And then on the right side, I have 6. Okay, remember we are isolating the y's, so I want to get the y's by themselves. So I do not want these 6 x's. So I'm going to take away 6 x's on the left, which means I also need to take away 6 x's on the right. Okay, so from here, if I look at what I have left, on the left side I have 3 y's, and then on the right side I have the 6, and then I have minus 6 x's. All right, and then always our last step is to do that divide. So we're going to divide by that 3. So now I'm going to have y equals, and again, I prefer your answer would be right if you left it like that, but I prefer to actually divide it out. 6 divided by 3 is 2. And then negative 6 divided by 3 is negative 2x. So that's what my answer would look like. So hopefully you did a nice job on that. But if not, we'll practice some more later. All right, number 7, these ones are a little bit different. We've got volume equals LWH. So this might be a formula. It's the volume of some sort of cube, a rectangular prism. So we're going to go ahead and draw our mobile valence. We just got a little bit, we're going to solve for W. Okay, so on the left side, we have V. On the right side, I'm just going to put that we have an L and we have a W and we have an H. So this is just kind of weird. We might not even want to draw. I don't even think I'm going to draw a mobile valence for these ones because these ones are just a little bit weird. I'm going to simply circle the W, okay? And I'm going to come over here just a second. Please remember in the first problem that I did, when we had 2x equals 6, when I was solving for the x, I divided by this 2. It was right next to the x. It was multiplication, and to undo multiplication, we divide. So if I have volume equals length, width, height, I want the W by itself. I do not want the L. I do not want the H. So just like over here, to get rid of the 2, we divided by 2. To get rid of the L and the H, we're going to divide by the L and the H. Okay, so my answer is going to be V over LH equals W. It said to solve for W. It says W equals. So I did solve for W. All right, so let's see if that made any sense at all. Okay, this time we are solving for K. So I'm solving for the K right there. All right, again, this time they're all next to each other, so that does mean multiplication. So if I do not want the I and the L, to get rid of it, I'm going to divide. So I'm going to divide by the I and the L. So if I just rewrite, I have M over IL, and that is now equal to K. It did say to solve for K. It does say equal K, so I did solve for K. Alrighty, your turn. Okay, so if we have solving for R, we have D equals RT. So I'm just going to give you a minute. You try it, see how you do, and come on back. Alrighty, welcome back. We are solving for R, so I'm going to go ahead and circle the R. And notice over on this side that I don't want is the T. And so just like if it was a 2R or 5R, whatever, we know we're going to divide. So to get rid of the T, we're just going to divide it out over on the other side. We actually are dividing it out over on this side too. And so we are left with D over T is equal to R. And now we're solved for R, so we're good. Okay, I'm going to go back just for a second here. I'm going to come to this formula right here. Once we have solved for W, I'm going to show you what could happen. Let's say somebody told me that the volume was 100 centimeters cubed. They told me that the length was 10 centimeters. And they told me that the height of the box or whatever it was 5 centimeters. And then they said, what is the width? Okay, we could actually, now that we have the formula solved for W, we can just plug in what they gave me. The volume they told me was 100. The length they told me was 10. And the height they told me was 5. And then we could work this out. Following our order of operations, we need to do multiplication first. So 10 times 5 is 50. And then 100 divided by 50 is 2 centimeters. So the width would equal 2 centimeters on that problem. Okay, and then I'm going to go to problem 9. Let's say somebody told me that the distance somebody traveled was 22 centimeters. Well, we'll do meters maybe. How about 22 meters? And the time that it took them was 6 seconds. Okay, so if that were the case, we could just easily, and I'd say, what was their rate? How fast were they going? Would be the question that we'd be answering. So we would simply just need to do the distance, which is 22, and we could divide it by the time, which was 6. And if you do 22 divided by 6, I believe you get 3 point. Let me just verify. No, just a second. 6 goes into 22. 318. 4, 6, 2/3. Okay, so this would be 3.6. Ooh. 6, and I'm assuming that most problems are going to say it around to the nearest hundredth. So if we rounded to that place, it would be 3.67 meters per second. So that's how you might apply the formulas once you do that. So hopefully now you are able to rewrite an equation or solve an equation or formula for a specific variable.